Welcome. Please wait while Time Machine is loading. Time Machine is a tool that is concerned with addressing the present and future challenges of our aging cities. Think of challenges concerning the preservation of our urban heritage, like pre-war architecture, frozen historic districts, and historical monuments. Or think of other challenges regarding obsolete elements of our urban fabric, like vacant buildings or subsidizing soils. So, how should we deal with our aging cities? Do we keep the past and therewith hold on to the old? Or do we renew, replace, or simply demolish all of what we consider old in our cities? Or can we maybe think of other interventions that are more suitable? Time Machine aims to reflect on and respond to these questions regarding the challenges of our aging cities. Let's first click on the Analyze tab and let's find out what we can consider old and where we can find it. As you can see, we can investigate the old on three scales: planet, city, and fragment. Let's start off with the planetary scale. Here we analyze what is old by mapping aging environments and processes on a world map and assessing how these have developed over time. Subsequently, we can determine what cities are at risk of different types of aging. Let's have a closer look at what we can investigate. As you can see in the Layers window, the old manifests itself in different ways, from historical monuments and aging homes to office vacancy and land subsidence. Time Machine aims to reflect on and respond to these questions regarding the challenges of our aging cities. The tool does so by analyzing what can be considered old, outdated, or obsolete in our built environment, by presenting a set of interventions to respond to the aging of our built environment, and by assessing the implications and impacts of varying interventions. This might sound like a lot. Let's put the tool to use and give you an example of how it works. Let's click on one of the layers and find out where in the world its risks are most pressing. Let's click on the soil subsidence layer. This will give us insights into what cities are sinking as a result of aging soils and are consequently at risk of flooding. To no surprise, places like Amsterdam and Venice have been at risk of sinking and flooding for a long time. How has this changed over time? We see that today many more cities are at risk of sinking and flooding. By 2100, many more cities will be at risk. Look at Lagos and Houston, for instance. Now, let's have a look at obsolete buildings. Let's investigate vacancy. Vacant, unused offices have been a trend of concern in recent times. Studies have predicted that office vacancy will only increase in the post-pandemic city. Cities with high property values, like New York and London, are going to witness how companies will, in increasing numbers, terminate their office lease. Let's now have a look at what cities are doing to preserve the old. Let's click on the UNESCO layer. In an attempt to preserve their cultural heritage, many cities have started to list their districts and buildings into the UNESCO World Heritage List. These maps show us that such listings are predicted to increase over time. To conclude, let's have a look at the overlap of all of these aging environments and processes. Clearly, many places are or will be at risk of different types of aging. Now that we have a better understanding of the aging that cities around the world are subject to, let's pick one to further investigate and later on intervene in. Let's take the magnifier at the top right corner and zoom into the world map. Let's choose a city with many aging risks close to home. How about Amsterdam? Now, let's map aging processes the same way we did before, but on a local scale. Let's first investigate the history of the city by looking at the construction years of buildings in Amsterdam. Let's click on the building age layer. What we can conclude from these maps is that many of Amsterdam's houses, especially in the city center, were built over 3 centuries ago. These houses tend to be subject to different types of aging. These range from the decay of their wooden foundations to the poor insulation of their walls. Let's now have a look at how much of Amsterdam is subject to preservation. How many districts are considered townscapes and cityscapes, and how many districts belong to the UNESCO World Heritage List? Let's have a closer look at the implications of preservation of Amsterdam's historic center and its canal ring. Let's click on the layer to gain deeper insights. As can be read here, building an Amsterdam center is close to impossible now that it has been listed in UNESCO's World Heritage List. This might become a growing problem as Amsterdam's housing crisis is reaching its peak. If not in the center, where can more houses be built to meet the growing housing demand? Let's move on. Let's have a look at Amsterdam's aging soils. Let's further analyze land subsidence in Amsterdam. As we can see, much of Amsterdam's outskirts are subject to sinking. Let's click on the map for more information. Here we can read that places like Duivendrecht are expected to sink up to 60 centimeters by 2050. Upon closer look, we find that Amsterdam Center is also expected to sink. It is expected to sink between 3 and 10 centimeters by 2050. Fixing the decaying wood foundations of old houses in the city's historic center is particularly expensive. Indeed, these costs can be up to €100,000 per home. Now we have a better understanding of the various aging processes that Amsterdam is subject to. Let's choose a 2x2 area of investigation. After, we can start intervening. Let's choose an area that is home to some of the aforementioned aging environments and to some of the aforementioned aging processes. Let's click on this area right here. This area is home to historical buildings, a significant amount of old dwellings, as well as subsiding land. Have a look at the axonometric view of our chosen area. Let's also have a good look at the different elements that make up its urban fabric. As you can see, this area is home to quite a lot of old buildings, mostly residential buildings. Almost a third of them were built over a century ago. Now we have chosen our 2x2 area of investigation and understand how it's aging, let's start intervening. As you can see in the window on the left, the Intervene tab consists of 3 elements: filter, action, and parameters. Let's go through them one by one. By clicking on filter, we can choose where we want to intervene. Do we want to counter aging in buildings, infrastructure, public space, or in green spaces? Let's say we want to intervene on our aging buildings. We then have to specify on what type of buildings. So this can be any type of building. The buildings you choose to intervene on can be residential, industrial, commercial, public, or office buildings. Another filter you could choose from is building age. You could, for instance, choose to only intervene on buildings that were built over a century ago. What is important to note is that you can use multiple filters at the same time. You could, for instance, select all building types or all building ages. You can also click on the reset button to unselect all of the previously selected filters. Let's not select any of the filters for now and have a look at the actions. Now we have unfolded this tab, we have an overview of all of the actions we can apply to our aging built environment. Let's start by looking at the first action on the list, remove. By clicking on the information icon, a pop-up appears. The first page provides the user with information about the action. It presents a definition, a description, as well as the parameters that are relevant to the action. Additionally, a moving GIF illustrates its spatial definition. The second page informs the user about the precedence and shows where the action was applied in the past. This same info is available for every action. Let's look into some of the other ones. For example, lift. Or extrude. Or cover. Or repurpose. Anyway, you get the idea of what actions you can pick and how you can make an informed decision about the most suitable action. For now, we will not choose an action. Let's click on the Assess tab and see what the implications are when we do not intervene. In the right window, we see the associated impacts appear. These are divided into surface measurements, numeric measurements, and impact measurements. Put your cursor on the time slider and see what the impacts are over time. Let's go over our 3 types of measurements and see what happens. The first type of measurements are the surface measurements. These cubes represent all of the built environment that we can intervene in. In other words, the cubes represent the filters that we choose. However, since we didn't choose any filters this time, nor an action, we do not add or remove any of the built environment. So this simply means that the cubes remain the same. Click on the different cubes per filter and have a look at their measurements: type, monuments, function, and age. If you want to see all cubes at the same time and compare them, you can click on the information icon. Importantly, depending on your chosen filter and action, the cubes will change over time. Let's close this pop-up and let's see if other measurements have changed over time. The second type of measurements are the numeric measurements. Here you can see how all of the relevant measurements were calculated. These calculations change depending on the action and were calculated based on empirically sound assumptions. Note that despite not applying an action, population in Amsterdam is growing, and that waste production, energy consumption, and CO2 emissions are increasing. Importantly, with an increase in population, we note a decrease in floor surface per inhabitant. Again, this shows the aftermath of the current housing crisis that Amsterdam is facing. Now, let's close this pop-up and have a look at the third type of measurements, the impact measurements. In this pop-up, we can see the expanded impact measurements. This type is called a pi radar diagram, but we'll call it the impact wheel. This expanded wheel shows three pillars: environment, society, and economy, each divided into subsections. It aims to assess the impact of our actions, or perhaps the lack of actions, on these three pillars over time. Note that again, these estimations are based on assumptions which may or may not be interpreted differently. So, let's have a look at how it works. Let's project ourselves once again into the future and let's see how the wheel changes. As we can see, the wheel has changed over time. The bars going inwards indicate a negative effect. Note the negative impact on the floor surface, caused by the lack of floor surface per inhabitant. Clearly, there's a lack of housing in Amsterdam, which has negative long-term effects. As we've seen in the analysis part of the tool, the preservation of old architecture and limitations on building in certain districts is contributing to the current and future housing shortage. Can we come up with an action to solve this problem? Alright, let's go back to the Intervene tab and let's see if we can find a suitable intervention. As you know by now, we start to select our filter. Given the fact that we want to act upon the aging housing stock to address the population growth in Amsterdam, we click on the residential building filter. Now we have our filter, let's choose an action to apply on residential buildings. How about we choose extrude? This action allows us to add extra floors to our houses. Let's now choose our parameters for the intervention. By changing the parameters, we can control the number of buildings that we will want to extrude per year and the number of layers we would like to add. Manipulating these in different ways can of course have very different implications. So let's set the filter at 15 buildings per year, and we will add 10 layers per extrusion. Now we have our intervention set, that is filter, action, and parameter. Let's see what happens over time. To evaluate this, we click on the Assess tab. Time to assess the intervention over time. For this, we use the time slider. We move the slider into the future. Have a look at the axonometric view and see how it changes over time. As you can see, after 80 years of extrusion, a lot has changed. Now, let's take a closer look to our measurements. Let's open our surface measurement tab and make sure to put the time slider back to 2020. Time to find out how the built environment changes over the years. As we can see, only the surface of residential buildings has increased. In the cube, however, the change is barely visible since the added surface still represents a small portion of the total residential surface in 2020. Let's leave the cube view and have a look at the impact. For this, again, we go back to 2020. Let's select the impact wheel. We project ourselves in the future and assess the impact of our intervention. Note that the societal impact on floor surface is still negative, despite us adding many layers on residential buildings. This means that maybe we should tweak our parameters to see if we can keep up with the population growth in Amsterdam. Let's save this assessment to compare it with our future interventions. Let's go back to our intervention tab and let's edit our parameters. We now increase the number of buildings we want to extrude per year to 15 and the number of layers to 25. Let's see if this is enough by clicking on the Assess tab. If we now take a look at the measurements changing over time, we can actually see a positive impact on society. Let's see what happens to our impact wheel over time. We open our impact measurement pop-up and start projecting ourselves into the future again. This time, we made a positive impact. As you can see, we've provided enough, if not more, floor surface to the case study area to enable it to endure Amsterdam's population growth prognosis. Let's save our assessment with this parameter too. And let's have a look at the Compare tab and see the differences between our interventions. Let's have a look at the Compare tab and see the differences between our interventions. Here we can see 3 cubes. One of them illustrates the implications of not intervening at all, and the other 2 illustrate the actions we just saved. We can use the Compare page to compare and contrast our actions and see how they have different impacts. In this particular example, you can clearly see the positive impact of extruding residential buildings with the parameters we used the second time. Note that this comparison can be done for different actions, different years, and different parameters. We take our time slider back and now have a closer look at how the buildings will change over time after we implement our action. Let's select this magnifier icon to open a zoomed in view of our case study area in a pop-up. In this close-up view, we can have a better look at what happens in the model over time. Now, let's go back to the axonometric view. We now want to try the pedestrian view in our model. To do so, we select this small icon and we place it anywhere in our case study area to open a pedestrian view in a pop-up. Check out how the action looks in real life. To conclude, there's a wide range of actions and parameters that we can implement and tweak to assess different aging processes and elements within the built environment of Amsterdam. This time, we extruded buildings to solve Amsterdam's housing crisis. While in reality, extruding houses is difficult in many districts in Amsterdam because many are subject to strict preservation frameworks, we hope that informing policymakers of the implications of this particular action will make them think about sustainable ways of preserving the old while allowing for urban regeneration at the same time. Anyway, while we could assess many other aging parts of Amsterdam's built environment, like its subsiding soils for instance, it would be fun to put Time Machine to work in a completely different urban context. Let's go back to the Analyze tab and let's look for a new city to intervene in. Now we're back in the Analyze tab, let's evaluate the different types of aging on different scales again. Like last time, we should start off by checking out aging on the planetary scale. Let's overlay all of the aging layers again, but let's zoom into a different city this time. How about we go for New York? Let's further investigate aging processes and elements on a more local scale. How about this time we evaluate office vacancy, a growing problem in New York and other OECD cities. When we click on the layer, we can learn more about the office vacancy in New York. We see that at present, office vacancy is the highest in decades, with 16% of all offices being empty. This percentage is expected to grow following the pandemic-induced shift in the way we work. Now, just like last time, we'll choose a 2x2 area of investigation. Let's choose this area right here. Have a look at the axonometric view and the surface's measurements, and get ready to intervene. Now we're in the Intervene tab, we should find out if we can do something about the office vacancy in New York. Let's start off by choosing offices as a filter. In terms of actions, we can consider a few. How about remove? By removing vacant offices, we mitigate vacancy levels and create more public space in the city. In terms of parameters, we can choose to remove 2 office buildings a year. Have a look at how the case study area changes over time following this action. Now, let's take a closer look at the measurements. How do you reckon they will have changed over time? The impacts of the remove action seem to be really positive in 2050. Yet, after these impacts become negative, what could have happened? Let's go to the Compare tab and find out. What we can derive from this window is that until 2050, reducing office size is a good idea, as it creates public space, which in turn serves society. Yet, in 2050, the vacancy has dropped to 0 already. Removing offices from this point onwards is not such a good idea anymore. This is visible in the impact wheel, which goes down again. Now that we know this, let's go back to the axonometric view of our case study area for the last time. Let's have a look at how the urban fabric changes over time following the selected action. In summary, we have shown again how we can intervene in an aging built environment. This time, we removed office buildings to create more public space. Maybe next time we can assess the implications of repurposing offices into, let's say, residential buildings. Perhaps this could, by adding housing stock, help to drive New York's rent down. Or maybe next time we can try to address a completely different issue that relates not to New York's aging built environment, but to, let's say, Hanoi's aging built environment. Time Machine provides you with a systematic and global way of intervening in cities, which helps to develop a common and universal approach to the inherent problems that affect all cities. Not only does the tool help you to test different design interventions on our existing built environment, it also helps you to evaluate their potential implications. Time Machine helps you to envision the future of your city's past.